the NTSB has finally issued its preliminary report on the Francis Scott Key Bridge collapse. And as you can see right here, it's dated today, May 14th, 2024. Marine Investigation Preliminary Report.
Think I'll give this little tug a looky loo. Check for safety violation.
And they titled it here, The Contact of Container Ship Dali with the Francis Scott Key Bridge and Subsequent Bridge Collapse. Accident number there as well. And as I'm going through this report here, I'll keep things as simple as possible for all of you non-technical folks out there. Trust me, this will be very easy for you to understand. They even have a docket page set up for it, but there really isn't much info there yet because if you click on the docket, there's no information there for the public. We don't know when it will be there, but hopefully it will be there because this is where we can go to look at all of the evidence that they're looking at. And it's really no small coincidence, in my opinion, that they waited until today to release it, because originally they said it was going to be in early May. But I think they did it because they wanted to wait until after the sixth construction worker was recovered and brought up and reunited with his family. And also they waited until the day after the bridge truss was blown off of the bow of the Dali. I mean, as soon as that happened yesterday, bam, this report shows up instantly today. Okay, on this report, I'm not going to bother reading this opening paragraph to you. We all know what happened there that night. They also showed this kind of angle photo, which I liked because it shows clearly here how that pillar just fell over and landed on the starboard side of the bow. And then the 4-lane road fell on top of it with the cone still standing up. That's amazing. Now, when they're talking about the accident events, they're telling us here about the engine. Okay, and the engine was a single slow-speed 55,626 horsepower diesel engine, and it was directly connected to a single right-turning propeller. I think I had seen comments from people at the beginning that assumed it was a dual propeller ship, but this ship only had one propeller on it. And this is an important point here, too. To run the main engine, one of the vessel's 4 diesel generators must be operating and supplying the vessel with electric power. The emergency generator alone cannot be used to restart the main engine. So, for example, here is a simplified view of their online electrical diagram aboard the Dali. And so these right here are your 4 diesel generators. Okay, so these generators are the ones that have to be on in order for the main engine to operate. And if these go off and only this one right here, the emergency generator is on, it cannot operate the engine because they're not connected on the same power buses. And I'll go over that with you in a second. I will go over this with you in a minute to explain how this whole system works. And they pointed something else here that was kind of important too, is that if you want to change directions here, the engine would need to be stopped and then restarted in the opposite direction. So a lot of people had asked me in the earlier days, why didn't they just put the reverse thrusters on and go backwards? You can't, because you got to stop the engine, change the direction, and then boom. And then you have to restart it all over again, and then you can go. And this is pretty cool. So they gave us a glimpse into the engine rooms. And this is the main engine room right here, looking aft. And this is the main engine. And so right here, you're looking at NTSB examiners, inspectors right here, and on the lower level of the engine room, and they're looking towards the bow. This view is towards the bow. Okay, but this is something else that is interesting to note here is that the engine was fitted with alarms and automatic shutdown features to prevent damage to the engine if supporting systems required for its operation, such as lubricating oil pump or cooling water pump, were lost. So if loss of electric power occurred to either of these 2 pumps here, the engine would shut down automatically. As part of a multi-step sequence to restart and operate the main engine after a shutdown, the lubricating oil and cooling water pumps would need to be restarted. So if we come back here to figure 5 and take a look at the electrical diagram here, we see that generators number 1 and 4 here, here's 1 over here, and 4 over here, are both rated at 4,400 kilowatts, and 2 and 3, which are these 2 in the middle, were rated at 3,000 kilowatts. Okay, and both of these here are connected to, this is a 6,600 volt high voltage bus. Okay, this is how their electrical system works right here. So this line where you see the HVR, all of these are connected to this high voltage bus. And normally in operation, you would have 2 of these generators on like this and 2 of them off, and they're switched off. So that's how you can tell right here that these are in the open circuit configuration here. When the ship is off and running, you have two of these diesel generators are running. So remember, there's two power buses on this ship. The high voltage one here is 6,600 volts. And then there's a lower powered bus that you can see right over here, which is 440 volts. Now this one powers all of your other stuff here, like the emergency generator and most of your little pumps and other things, and the lighting, the emergency lighting, and other systems like that don't need 6,600 volts. So what happens is, from this bus right here, which is 6,600 volts, the voltage passes through a transformer here that has enough windings in it calculated to convert it from 6,600 volts down to 440 volts. So that's how that works. That's what these are. And then this HR1 and this LR1 here, these are breakers. So that's the high voltage breaker right here. HR1 is a high voltage breaker, and LR1 is a low voltage breaker. Think of it as a fuse. So if you were to go to your electrical panel in your house, this would be one of those switches in there, essentially. The report shows us that here's where it left Seagirt Terminal. It was pulled away by the tugs. It was set free on the Patapsco River, and then it crashed into the bridge here. So the report gives us a little bit more detail into who was on board and everything with the crew. So at about, looks like right around midnight, the Association of Maryland Pilots, there was a senior pilot and an apprentice pilot boarded the Dali. And here's the cargo. It had 4,680 containers, which was 56,665 metric tons. During the master pilot exchange, the senior pilot asked about the vessel's condition, and the captain reported that the ship was in good order. Or was it? I guess that's what we're going to find out in the report, or sometime in the future. So these are the two tugboats that pulled it away from the dock. And it says here that generators number 3 and 4 were supplying electric power to the vessel. So if we look at the diagram here, they're saying these right here, generators 3 and 4, were supplying power to the vessel. Now you can see their breakers are green, so they're on, and they're connected directly here to the bus, the 6,600 volt bus. These two generators were off at the time. So we can see that power is coming from these two generators through the 6,600 volt bus, through this path here, through the transformer, through this other path here, down here, to the 440 volt bus. So somewhere around 12:45 or so, the pilot ordered the main propulsion engine to dead slow ahead. Then about 20 minutes or so later, at 1:07, the senior pilot gave orders for the tugboats to be let go per normal practice. And this is where a lot of people were saying, wait a minute, why didn't those tugboats keep towing the ship all the way out the channel and past the bridge and everything until it was safe? Well, they may look at changes for that now in the future. Who knows? It depends on how well they protect the new bridge. But at this point here, the senior pilot handed control over to the apprentice pilot and remained standing by. And so far, all of these orders given correspond with the estimated ship speeds with the vessel going. So here's the engine maneuvering table. And so it looks like once they told him to go slow, your loaded speed right here should be about 10 knots. See that right there. Okay, so they were going slow ahead, everything was fine, and here's where the trouble starts. So at 1:25 in the morning, the Dali was 0.6 miles or 3 ship lengths away from the key bridge, when the electrical breakers HR1 and LR1 that feed most of the vehicle's equipment and lighting unexpectedly opened and tripped. So these are the two that tripped right here, HR1 and LR1 right here. Both of these tripped. They both went open on us. And when these go open, you no longer have any voltage going from the 6,600 volt bus here to the 440 volt bus right here. And I'm sorry about these things that keep popping up. I have no way of controlling those. That's on their document. So if you cut this right here, you have no power going through the transformer, no power going through here, and then hence there's no way to get to anything else on this bus here. So that's why we saw on the video when the ship was approaching the bridge that all of a sudden the power just goes off. Now, it's important to note here that the report here says that generators 3 and 4 continue to run and supply power to the high voltage bus. So that means these two kept going. There was no problem with them. They were happy, and they kept providing the high voltage power to the bus. Now, it says here that most of the bridge equipment also lost power, and the voyage data recorder lost vessel system data feeds. The bridge audio, however, continued to be captured. We don't know if it was because it was battery backed up or where it was getting its power source. They're not very clear about that here. Herein lies the rub, though. You see, even though these two generators were on and still giving power to the main engine, problem is some of the systems driving the main engine require the lower voltage here, like the pumps. So like I just showed you here, even though the main propulsion diesel engine was independent of the vessel's 4 diesel-driven electrical generators, but the loss of the power to the pumps required for its operation resulted in the main engine being automatically shut down, and the vessel lost main propulsion, meaning its propeller stopped. And let's face it, folks, you got to have that propeller if you want some efficient steering. You need that water stream going past the rudder. Okay, so here the report then goes on to say the loss of electrical power stopped all 3 steering pumps, and therefore the rudder was unable to be moved. At the time, the ship was on a heading of 141.7 degrees, a course over ground of 140.8 degrees, and a speed over ground of 9 knots, with the rudder amidships at 0 degrees. So now at 1:26:02, which is basically 1 minute and 2 seconds after the power goes out right here, the VDR, which had stopped recording vessel system data when the blackout occurred, resumed recording the data. The VDR audio recording had not been affected by the blackout, as I mentioned before, and the Dali's heading was now 144.3, and the course over ground was 142.7, and it had dropped its speed a little bit down to 8.6 knots. So the apprentice pilot called the pilot dispatcher by mobile phone. And so then a few seconds later, the senior pilot, who had regained control from the apprentice pilot by this point, ordered a 20-degree port of rudder. I don't think they had control of the rudder at this point yet. This is what I'm unsure of. The emergency generator started and connected to the emergency bus, so its breaker, of course, would have closed, so that could happen shortly after lost electric power. Now, they're not saying how long it was, but it must have been at least a minute or so, maybe a minute and a half, I forget, because we saw how long it took for the lights to come back on. And these emergency generators are supposed to kick in like 45 seconds. So what they're saying that happened was this generator here clicked on and its switch closed. So now this emergency generator is supplying the 440 volts to this bus here. Meanwhile, the other bus, the high voltage bus, is still getting its power from these 2 generators. So the NTSB is still trying to find out the exact time when the emergency generator started. So it looks like even they don't know at this point. So as soon as that emergency generator came on, you can see right here, the emergency bus was powered, emergency lighting, navigation, radio equipment, alarms, and other emergency equipment would have been available. And the designated emergency steering pump number 3 would have been available to turn the rudder at its low speed setting. The problem here, see, without the propeller turning, the rudder would have been less effective. So we don't even know if it was having any effect at all. Okay, so then what the crew did next was they closed the breakers HR1 and LR1, reconnecting generators 3 and 4, and restoring electrical power to the low value bus, supplying electrical power again to the entire vessel. So what the crew did was they reclosed this breaker that had popped open, LR1, and then HR1 head. So this then allows the 6600 volt bus to go through the transformer to the 440 volt bus and get everything going there. So here we go at 1:26:39. That's when the pilots called for tug assist. So that's about a minute and 40 seconds from the time they lost the power. So the Eric McAllister was 3 miles away and immediately answered, heading towards the ship. But you know, there's no way it's going to catch up. When you're 3 ship lengths away, you're from the bridge, you're not going to catch up when they're a couple of miles away. So then at 1:27:01 right here, the senior pilot ordered the anchor to be dropped, and the crew began the process to drop the anchor. The pilot's dispatcher called the MDTA police duty officer and relayed the ship had lost power, and that's when they notified the Coast Guard about Dali's loss of power. So they were able to restore electrical power to the vessel, but when the ship was 0.2 miles from the bridge, a second electrical blackout occurred because the diesel generators 3 and 4, the breakers that connected those to the high voltage bus, so those breakers opened, causing a total loss of electrical power. See, so this is what's perplexing here, because the first power outage was caused by these 2 going here. But now, on the second time around, the power outage was caused by both of these opening at the same time. So for both of these to pop open at the same time, there must have been a huge draw of current somewhere along in this system here. It couldn't have come from here because these are open circuit. So it was coming from here, here. It could be anywhere along the line. It could have been bad transformer. It could have been maybe bad breakers here causing something. It could have been a short somewhere here in the low voltage bus, something here drawing too much current. It could have been something on the high voltage bus shorting. So good luck trying to figure out where the path was to what exact appliance on there was drawing too much current, if that is indeed what caused both of these to pop. If they both popped, it says to me there's just too much current in here, and they both did their job and popped at the same time. They went open circuit. So in other words, they would have changed here. See this green here from closed to open. So because they were already connected to the emergency bus by this time here, the emergency generator provided electric power to all of the emergency equipment continuously through this second electrical blackout. Okay, so by this time now, and this is where this whole thing is just getting so tricky. But it's pretty amazing watching it in action. Generator number 2, which was previously started automatically because it was already in standby mode, thus connected and restored power to the high voltage bus. So again, coming back to our electric diagram, remember these two guys are open, so DG4 and 3 are out of the equation right now. Okay, so diesel generator right here, number 2, was online and it kicked in, and then this switch will close now, and now it provides power to the 6600 volt bus. And so now the ship has its power restored once again. So they've recovered from 2 power outages on the ship here caused by 2 different scenarios. One was HR1 and LR1 popping. The second one was DGR4 and DGR3 popping. So now that they have power restored the second time, here we are at 127 and 23 seconds, the pilot ordered the rudder hard to port, 35 degrees. The problem with that, though, is that at this point, the main engine was still shut down, so there's no propulsion to assist with steering at this point in time. That's the problem that they had. And so by this point, they're heading right at that southern pier, number 17. And so basically 2 seconds after that, one of the pilots made a call by very high frequency marine radio to warn the waterborne traffic. And now at 1:27:32, which was 31 seconds after that second blackout, the crew manually closed breakers HR2 and LR2, restoring power to the low voltage bus, which was powered by generator 2. So they had regained the electrical power before the vessel struck the pier, but again, they were unable to regain propulsion at this point. So they closed these two, HR2 and LR2 now, so that you could get power going through here, this path here, all the way down to the low voltage bus right there. You can see it's a nice redundant design. So they were able to take advantage of this redundant design when certain breakers here popped open. They could reroute around them. That's what they were doing. Yeah, so remember the call went out on the radio here at about 1:27. At almost 1:28 in the morning, this is 1:27:53, the MDTA duty officer right here, you can see he says he ordered the units stationed at the ends of the bridge to close the bridge to all traffic. Now we know that the northbound traffic was stopped, but the southbound traffic had not been stopped quite yet when, in the videos that we saw, but eventually it was, and we saw the last vehicle that went over the bridge and traveled and made it safely, and basically 30 seconds later, the bridge came down. So right here at 1:29:10, basically a minute, they had just over a minute, maybe a minute and 20 seconds or so before the bridge collapsed to get those lanes blocked off. And I remember hearing the dispatch audio from the police the next day, and I heard them talking about driving up to warn the construction workers, but they just didn't get to it in time. They had no time. They were busy blocking off the traffic. And the one officer was saying, I'm going to go drive up and talk to the construction guys. But here at 1:29:10, the Dali's starboard bow struck pier number 17. And then we all know what happened after that. So the road maintenance inspector had been walking the length of the bridge when the ship struck it, and he ran north and made it to the nearest surviving span before the rest of the bridge collapsed. Wow. So he was uninjured, and one guy says one worker here was able to free himself from his truck and was rescued at 1:55. So basically about 25 minutes later, he was kind of stuck. I don't know where he was but they didn't really say here. But he hung in there for 25 minutes until they rescued him. And then at 1:34, Coast Guard issued an urgent marine information broadcast requesting assistance from passing traffic. Multiple agencies searched for survivors throughout the 26th. And then, of course, the rest is history. We know what happened after there. But according to the NTSB report here, it says the electrical power loss was only on one day, and that was on March 25th. So it was basically 10 hours before it left the port right there is when the Dali experienced a blackout. And it didn't look like it had anything to do with what we saw. So it says what happened right here. A worker was working on the diesel engine exhaust scrubber for the diesel engine driving the only online generator, which is generator number 2. So a crew member mistakenly closed an inline exhaust damper. So closing this damper blocked the engine's cylinder exhaust gases from traveling up its stack out of the vessel, and it caused the engine to stall. So it looks like this is the one here. They're talking about diesel generator number 2. They were making the adjustments on that when he closed the damper on it, and it caused the engine to stall out. So they lost power on this. It was the only generator at that moment in time that was putting voltage out onto this high voltage bus. So of course that takes out power to the whole. So of course this will take out power to the whole ship at that time. And so because generator number 2 went offline, generator number 3 kicked in and said, "Oh, I'm here. I'll take over." And he supplied the power to the 6600 volt bus. But something slightly unfortunate happened to the crew when they tried to close HR2 here and LR2 here, so that the power could get from generator 3 through here, down here to the low voltage bus. There wasn't enough pressure. And so this guy popped now. He popped open. It's like, man, everything's just going left and right now. And so sensing that the diesel generator number 3 had blown, diesel generator number 2 goes, "Hey, I'm here," and he kicks back in. So see how these redundant designs work perfectly for each other? So now he restores the power after that second blackout here. Remember, there was 2. This one went first, so number 3 kicks in, and then number 3 blew. When they were trying to close these breakers, number 3 blew, and then diesel generator number 2 kicked back in again, so he's back to where he was a few minutes ago, and everything's working normal again. Everybody's happy. So pay attention to this, because this is important now. You're using one leg or the other. And so since these 2 were closed, the crew decided, since they had been using this engine path here for the last few months, let's switch it over to this side. So they reopened these 2 here after they closed these here. So now this was the configuration that Dali left the port in, with diesel generators 3 and 4 running and supplying the power on to the high voltage bus, and then coming down through this path here to the low voltage bus. That's the configuration it had when it left port, like I showed you earlier. So this makes us wonder, these here, HR1 and LR1, are sort of, think of them as untested at this point, because they haven't been in operation in a few months. Was something wrong? Did something happen to the system in the few months that it sat there unused? That's something that the manufacturer, who was on site with the NTSB, will be investigating along with the NTSB. So the report here is also saying that Dali had this integrated control and monitoring system here, and it retains information related to the machinery and the system changes and resulting alarms, including vessel engines and the electrical power management system. So I imagine they're going to be looking through there to see if there's any timestamps or anything else that could tell them like when certain things happened and what order they happened, because it is important as to which order some of these breakers opened. So it says right here, they're still working to identify the causes of the breakers unexpectedly opening while approaching the key bridge and the subsequent blackouts. So imagine, let's just say, for example, this is one of the breakers right here. Imagine you're standing there and the thing just pops for no apparent reason. Maybe an alarm went off somewhere that said something was overcurrent. You can see a lot of meters over here. So I'm imagining here that they can tell on certain branches here who's drawing too much power. So right here you can see there's an NTSB investigator. He's examining the switchboard there. So this is the high voltage bus. Oh, and he's also putting the tamper evident preservation seals on there. See all of these stickers and stuff there? So he doesn't want anybody going in there and touching the panels, opening them up and messing with things and possibly tampering with evidence. Okay, the alcohol and drug tested, everybody was clean. Nobody had anything. They tested the fuel and they said the fuel was okay. There was no problems there. So this was one area where a lot of people thought, well, maybe it had bad fuel and it caused the engine to fail. But nope, they said the fuel was fine. Okay, now as far as hazardous materials, you could see there was 56 containers with them, and at least 14 of them were contained right up here on the bridge. So you can see, here's the 4-lane highway where it came crashing down on the bridge, and it damaged a number of these severely too. And this is what they had in them. Now, some only had perfume, but some had like sulfonic acid and other hazardous substances. So you can see where they were mostly located at. So that's why when they blew the bridge yesterday, they decided not to put some of the charges right around this area here, which is why you saw how this part of the truss sort of somersaulted up and over itself rather than sliding down into the water like they showed us in the animation, because they decided at the last minute not to blow some charges over here where there was potentially a danger of fire. Yeah, so here's the table of all of the hazardous materials. Those of you who are MSDS freaks, you can go and have a look at this and track them down. Of course, they have the background on the bridge that it opened on March 23rd, 1977. And there's the continuous truss part that collapsed. The Dali hit and is still sitting right here as of today. Now, some of you watching this video in the future will know that the Dali is, of course, gone. But this is where it was. It came into here, and there's 4 pillars, 2 on this side and 2 on this side. And it smashed through the northern 2 pillars. But once they started to collapse, these other 2 broke down as well. This part of the bridge here survived, as did this other part over to here. The report goes on to mention the pier protection, and it basically showed, here's that dolphin. And remember, I started showing you these like the first couple of days when I was doing my first early videos on the collapse here. So the ship came in at too much of an angle that it bypassed the dolphin. And they said dolphin number 1 is located 491 feet away from the pier. That to me is just way too far. The ones in the Sunshine Skyway Bridge in Florida, where I showed you here in Tampa, were like 60 feet round. So they're almost 3 times the size of these guys. And they were a lot closer to the pier to be able to deflect a ship coming at it sooner. There you can see where the Fort McHenry Channel passes right through the Dali. And so here they showed close-ups of the dolphin there with just some basic rubber and wood around it. And then the pier fendering system here around the pier, very inefficient. It's about as useful as screen doors on a submarine. It says the last inspection on the bridge was in May 2023. And the last underwater inspection was in March of 2021. And they said that it listed the bridge in satisfactory condition. So it looks like in the early stages of the investigation here, it doesn't look like there was anything wrong with the bridge that it would have just caused it to come right down. I mean, you hit a major part of the superstructure like that, you're going to knock it down. So again, they're sort of reiterating here that they're going to continue evaluating the design and operation of the power distribution system, including its breakers. It says here the NTSB is working with parties to immediately assess their bridges and determine whether pier protection needs to be improved. So, a lot of people had been asking me about this earlier on. Why aren't they checking at other ports and stuff around the country? Yeah, they definitely should be, for sure. That the NTSB is examining, for example, like the Sunshine Skyway Parkway Bridge in Tampa. So as I showed you in some of my earlier videos, that has a world-class set of protection dolphins around it. And then the Queen Elizabeth Causeway Bridge also near South Padre Island in Texas. And of course, the I-40 bridge near Weber Falls, Oklahoma. They also noted that the detailed analysis of the VDR bridge audio and further validation of the VDR parameters continues. So I hope they release more of that information later on. Now, here on this channel, we do more than just engineering disasters. We do the Home Depot and Costco and Lowe's walkthroughs, and we also do the big DIY projects for your house. And after this video, make sure you check out this one over here of the double-decker cabinets that I did up in that kitchen. That's an incredible engineering project with a refrigerator, a large refrigerator at a 45-degree angle in the corner. Very difficult project. Check that one out. And then when you're done with that one, make sure you check out this video here, which shows you everything you need to know on how to install laminate flooring in your house. Well, thanks so much for joining us tonight, and we'll see you on the next one.